Hi guys, myself Dr. Sujatha, Associate Professor from Vignan University. Welcome to the today's session of Design and Analysis of Algorithms. In this session, we are going to discuss about brute force technique, which is extension for the last unit. In this unit, we are going to discuss about these topics: closest pair problem by using brute force technique, convex hull problem by using brute force technique, exhaustive search, advantages and disadvantages of brute force method. Coming to the first one, closest pair problem, which can be solved by using brute force technique. The closest pair problem calls for finding two closest points in a set of n points. Points in question can represent such as physical objects, as aeroplanes or post offices, as well as database records or statistical samples or DNA sequences, etc. Suppose, for example, an air traffic controller might be interested in two closer planes as the most probable collision candidates. A regional post service manager might need a solution to the closest pair problem to find candidate post office locations to be closed. So this closest pair problem involves finding the two closest points in a set of points in a Euclidean space. Usually it may be a two-dimensional space or a three-dimensional space. The brute force approach to solve this problem involves comparing the distance between every pair of points and keeping track of the minimum distance found as so far. Now, what is the algorithm for brute force approach? Here you can see the steps in the algorithm for brute force approach. First, we need to initialize a variable called minimum distance to the infinite. For each pair of distinct points, point 1 and point 2 in the set of given points, calculate the Euclidean distance between point 1 and point 2. If the calculated distance is less than the minimum distance, now we need to update the minimum distance to the calculated distance. So like this, we need to calculate the distance between all pairs of points. After comparing all pairs of points, minimum distance will contain the minimum distance between any 2 points in the set. Return the 2 points that correspond to the minimum distance found. So this is the algorithm what we have. Now here how to find the distance between 2 points. I already mentioned that we will use Euclidean distance. Here this is the formula for Euclidean distance. Here you can see point 1 is x1, xi, yi. Point 2 is xj, yj. I want to find the distance of these 2 points. Now, how to find the distance of these 2 points is distance of pi comma pj is equal to square root of xi minus xj whole square plus yi minus yj whole square. This is the Euclidean distance. Now we will see an example. Here you can see I have given in a two-dimensional plane, we are given with 5 points. A, B, C, D, and E. Now, first we are going to find the distance of A and B. So here, how to find the distance of A and B? 1 minus square root of 1 minus 2 whole square plus 2 minus 5 whole square. Then we will get the distance between A and B, which is nothing but 3.6. The distance here, you can see I filled the values of the upper triangle only. The lower triangle is not filled, because the distance of A and B is similar to B and A. The distance of B and C is similar to C and B. So that's why I didn't fill the lower triangle. Right. Now, here, first the value is updated with 3.6. Minimum distance is updated with 3.6. Initially, minimum distance is infinite. Next, we calculated the distance of AC. Now, 5.83. So, in the earlier step, the minimum distance contains 3.16. Now, this is the greater value. So, it will not be updated. Here, this is also the greater. This is also the greater. When I calculated the distance of B and C, now the 2.82 is less than 3.16. The minimum distance is updated with 2.82. So if you observe the distances of remaining points, this 2.82 is the minimum distance which is present between BC and CD. So the closest pair of points in the given example instance are BC and CD. And you need to make a note that this brute force approach has a time complexity of big O of n square. So I hope that you all understood the closest pair problem. So what are the applications of closest pair problem? It can be used in various applications. Finding the distance between any two objects. Wherever you want to find the distance between any two objects, you can use that closest pair problem. Thank you for listening.